Hello, I am Fleur, BIM Product Specialist at Bricsys, and today I welcome you to the in-depth session, Getting BricsCAD BIM Documentation Ready with Type Plans. In this session, I'll show you how you can customize your 2D generated drawings with the help of the BricsCAD BIM Type Plans functionality. For those of you who have followed BricsCAD BIM in the past, Type Plans is a continuation of drawing customization feature in the previous version. However, in V23, it comes with extended functionality and an entirely new user interface. I will show that in my demonstration later, but first let me explain you what benefits type plans have. With type plans, all BIM customers can create templates to apply a different visualization to their 2D plans, sections, and elevations. The change in visual style that is contained within these typed plans templates may include changes in their 2D geometry, such as the color, their line weight, etc. As such, by applying one type plan template, you can visualize exactly the data that you need in the way that you need it, without manually having to make all the changes. Something which would normally have taken days can now be done time and time again in a matter of seconds. On top of that, with typed plans, it will become easier to ensure adherence to office drawing standards or to local government requirements, and to achieve consistency across 2D drawings, especially on detailed design and building permit packages. If we zoom in on some of the details of this example drawing, made ready for approval by the Austrian government, we see that the drawing uses certain symbols for representing windows and doors. Also, certain color codes were used to represent certain materials or properties, for example, to differentiate between the to demolish status or the new status of an object. A final bonus of using type plans is that by reusing the same type plan on different BricsCAD projects, you really save yourself time and effort in the long run. So now that you know the benefits, let me show you how to get from the default BricsCAD BIM documentation style to your own office or government style with type plans. First, we will see if our model contains all needed data to be used in the type plan we envision. Next, we will see how the out-of-the-box BricsCAD documentation style looks on this drawing. Then, we will define some new symbols to be used by our type plan. If we have all the information ready to be used by our type plans, we can proceed to define some new type plans and change the visualization of the documentation. As soon as we have our new type plan, we are ready to see the visual transformation of our result drawing and compare it to the out-of-the-box plans from before. We will end the session by importing some more ready-made type plans and see the variety of possibilities that they allow. It will for sure convince you to try out type plans by yourself. So let us start by checking out our BIM model. Before we start on the type plans, we need to make sure that our BIM model contains all the data that we want to use in our type plan. Knowing and defining upfront which data you will need for the desired documentation style is an important part of the BIM process. In this model, we see that a lot of properties have been filled in. If we open one element and see its properties, we can see that a lot of properties were filled in, such as the building and story, but also the overall height and width, fire rating, etc. Some of these properties, like the name and number property, were even filled in with a script. It is very important to have sufficient metadata stored in your 3D model, because we can use the filled-in information for filtering out certain elements that need a similar graphic representation. When making a new project, your default documentation set will look something like this. The default look is defined by the BricsCAD BIM templates in the template folder and in the support folder. I won't go in depth about customizing these templates, as in V23 we can overrule these default templates in a tight plan instead, where we can specifically filter out the elements based on their BIM data and customize the generated lines per filtering. Now, in these default representation, we see that the windows are represented by their actual cut objects, and we would like to change this to symbols instead. To do this, we need to define a symbol inside of the window components. But first, let me explain you what a symbol is in BricsCAD BIM. A symbol is something that changes the representation of a 3D component in your model, like a door or window, either by adding some 2D geometry upon generation of the section, such as adding a door swing, or by replacing the representation of the generated object entirely with a new symbol. To do this, we can include one or more symbols inside our component by putting the 2D symbol on a layer with a dedicated syntax. For elements that are cut by the section plane, we use the syntax BIM_2D_sect. For elements that are lying in the back, we use the syntax BIM_2D_back. We then change the 2D to 2D plus if the symbol is just an addition to the actual geometry generated from the 3D object. As such, with symbols, we could make several representations of a window or a door. One for plans on 1 to 200, and one which is more detailed for plans on 1 to 100. In this next version of the BIM model, I already replaced my window components by a more detailed variant that includes symbols. This means that if I open a window, you can see I made 2 layers, each with their own representation of the window on them. One layer for 1 to 200, a simple line, and one layer for 1 to 100, which contains a more detailed symbol than the 1 to 200 layer. Later, in our type plans, we will thus be able to simply search for the correct layer name and turn them on or off according to which symbol we need in which type plan. A tip here is that you can use a parametric 2D block as symbol, and that you can link the 2D block's parameters to the 3D parameters of the component. In this way, my symbol will change in sync with the parameter changes of my component insert in the BIM model. By now, we know what type plans do, and we have done all the preparatory work. So it's perfect time to reveal to you the new user interface in which you can create and edit type plans. To enter the new user interface, simply go to the Files tab of the project browser and click New Type Plan. Then, give it a good name, such as Structural Plan 1 to 100. And you can now see that we have 2 tabs, one to add drawing overrides and one to add tag overrides. As soon as we click the Create New Override button, we will see that we enter the customizations. We see a filter list on the left-hand side and the customizations on the right-hand side. Now, you can click OK to save the type plan. If we want to edit it again, you can right-click the type plan in the Files tab and choose either Rename to rename it, or simply double-click it to enter the editor dialog again. We now saw the new user interface for creating and editing type plans. But you still don't know what all the filters and the different drawing customizations really mean, and how you can leverage their full potential. So let me tell you a bit more about that. I'll start with the filtering. You see, when I open the type plan editor, I can see a filter list at the left-hand side of the dialog. This list will be checked, starting from number 1 onwards and continuing down to number 2, 3, depending on the amount of filter lines you have created. BricsCAD BIM will then check if an entity falls into this filter, yes or no. And as soon as it falls into one filter, the rest of the filter list is not checked anymore. This means the order of this list is very important to get the desired result. If I first want to filter out all the walls and slabs, for example, we do this by creating a filter line, walls and slabs. And in the filter, I start by adding a filter expression. BIM type is wall. Now, this first filter will filter out all the walls. But we also wanted to filter out the slabs in the same filter, meaning we want to customize walls and slabs in the same manner. In this new user interface, it became very intuitive to do this. Just copy the filter expression, and an OR will be created. We can now change the BIM type is wall to BIM type is slab by double-clicking it and changing the filter. As soon as we did this, it means that with one filter line, we check if an entity is a wall or if it's a slab. And as soon as one of the two is true, it will customize the entity in the way we specify next. In essence, meaning that we will customize all walls and all slabs in the same manner. As such, we can make more and more filters. And in general, it's best to start with your most specific filter lines and then work your way to broader and broader filter lines. You can even leave your last filter line so generic to encompass all other elements, by just not specifying any filter expression in it, meaning all the reds, which hasn't been filtered out yet, will be customized like the last line specifies. In the case of this structural 1 to 100 plan, we first checked if there are walls or slabs. However, I now want to add an extra condition, namely that they are load-bearing. So, to both my filter lines, I add an implicit AND condition that checks if they are load-bearing. If the load-bearing property is true, these planar load-bearing elements will need a special treatment, as we will see later. Next, I want to check if there are any other elements that have the load-bearing property true, for example, columns, or any other type of object. So, I say other load-bearing elements. And I check whether their load-bearing property is true. Finally, all other elements can be customized by leaving the last filter expression empty. But we're not there yet. We now filtered out the correct elements, but we still need to customize them. We have 4 different types of customizations, which you can specify for each filtered group of elements separately. These 4 types of drawing customizations are the following: section result customization, center customization, symbol customization, and ply customization. I'll now cover each of them a bit more in depth, starting with the section result customization. With section result customization, you can customize how the lines of each element that is being processed by the section generation algorithm will turn out. To understand this better, we first need to understand which types of lines are made by this section generation process. For this, I've created the schematic drawing of a pyramid. In this diagram, the section plane is aligned with the blue square with the red outline. The green outline represents the background, which is essentially the elevation outline of the cut object. The red object represents the intersection boundary, which traces over the cut area. The blue hatch represents the intersection fill, as it shows the area of cut by the section plane. The orange hexagons represent the elevation fill, which refers to the area bound by the elevation outline. The pink outline represents the hidden lines, as it is below the blue hatch. The yellow outline represents the cutaway geometry, as it is above the section plane. Let's return to our type plan editor, and in the three dots under Add Customization, you can see the same options that we just discussed. As soon as you add one of these, you can then customize the lines corresponding with that option in the style that you want. Styles were now created on the fly and consists out of setting the lines visible, no or yes, setting the color, line type, line weight, and line type scale. Besides the different options which I demonstrated through the pyramid diagram, we have two more options: Override Hatch and Apply for Plies. Override Hatch allows you to specify how an entity's hatch appearance would appear in place of the default hatch pattern already defined within the physical materials library. If you check this option, you would get a section hatch and an elevation hatch field, which you can click to change the hatch pattern of section hatches and/or elevation hatches, maybe even including a background color for your hatch. You can further ensure the customization applies to the plies of the entity composition by checking the Apply for Plies option. For this structural plan on 1:100, I want to customize the load-bearing walls initially with a gray fill with a thicker but darker gray outline. To do this, I use the intersection fill option as well as the intersection boundary. Both of them will be set on a different shade of gray, and the boundary will be emphasized with a thick line weight. The background lines can go in a thin gray line so that they will fall more in the background. Here, we will leave the section hatches on a solid column. Now that we have the basic coloring of our walls and slabs ready, it's time to discuss the center customization option. Center customization determines the appearance of the center of planar or linear entities. The resulting center lines, for example, from cutting a wall center plane in a floor plan, can be customized like we customized the generated section lines before. We will not use this option in our structural elements type plan. So next up is the symbol customization option. In this symbol customization option, you can filter on the names of the layers which contain symbols. As such, you can only show the symbols you need on a specific drawing. If we would be making a 1:200 type plan, for example, we could only leave the simple 1:200 symbol visible. And the same goes for this 1:100 type plan, on which instead we will only show the more detailed window symbol variant by filtering and leaving visible only the 1:100 symbol layer. To do that, we can add a customization. Type in the layer name, give it a color, choose its line weight, and choose whether it's visible or not. If we don't specify a certain symbol layer, it means it will be customized as it is default, which means it will be shown. That's why for certain layer names, we specifically have to turn them invisible. Here, this is already done. So finally, let's return to the ply customizations. This can be used, for example, to highlight all the structural plies from only the load-bearing planar elements. To do this, we already filtered out all load-bearing planner elements, the walls and the slabs. Next, we come to the filtering of plies, in which we can apply a ply filter on default function of the material. If this is structure, we want the color to be red. So we will give both the intersection fill and intersection boundary a red color. The background can go again in a light gray style. We can turn off the section result customizations, as by using this ply filter, we don't need the section result customization anymore in this case. You can still use the section result customization for all other load-bearing elements, for example. But here we choose to turn off all the default section result customizations, and we only specify the ply customizations, saying one has a structure function and the other has no structure function. So we leave this filter empty and we give the colors a new color. We also make sure that we override the hatches to solid hatches once again. And as such, only the structural ply from the load-bearing planner elements will be colored in red. Now that we covered all types of customizations, you can apply this knowledge to the other filters we have created before. Here, I'll make sure that every other non-planner load-bearing object, such as a column, is also customized in red. And to end, I will color all other elements except the spaces and color them light gray. As such, only structural elements will visually pop out in red, as you will be able to see soon. But how do you create a 2D drawing that follows this type plan template? Well, we have a few options to do that. The first option is doing so on the fly. We just place a new view coming from a BIM section entity onto a sheet and apply a type plan to it right away. This can be done by right-clicking a BIM section entity in the Sections and View tab from the project browser and choosing Create Sheet from the pop-up menu. You will then enter the Create Sheets dialog, where you can choose the layout on which to generate the view, as well as the scale and the type plan which you want to use for this view. If left empty, BricsCAD BIM will generate the view with the default settings for section generation. Here, we will choose our newly created type plan that will replace the cut of the windows and doors by a window and door symbol fit for the 1:100 scale which we chose. Furthermore, everything will be colored gray, except for the structural elements that will be colored red. We accept the creation of the sheets with OK. In BricsCAD BIM, we want to give you full control over when and how you choose to update your drawings. This means that after creation of the sheet, you can now generate the 2D section by right-clicking the sheet and choosing Update Now. This makes creating sheets really fast in BricsCAD BIM, as you're not slowed down by a large amount of auto-generated drawings. The section will then be generated into a 2D result block that is stylized according to the type plan which you chose before. If we open the sheet by right-clicking the sheet and choosing Display View or Open Sheet, we will see that indeed the section has been generated onto a sheet in the style of our 1:100 type plan. Here, you see that the symbol is now indeed a 1:100 symbol and that the structural plies are colored red. So now you might wonder, can we still change to a different type plan afterwards? The answer is yes. You can still adjust the type plan that is being applied in the properties of the viewport that looks onto the generated 2D section. The second method of creating a 2D drawing that follows a type plan is just that. Generate a 2D drawing, go to the viewport that looks onto it, and from the Type Plan drop-down in the Properties panel, choose a type plan present in your project. By the way, the list you see here will become longer as soon as we have imported a few other type plans. But first, let us inspect the generated drawing a bit deeper to see what changed. First of all, and pretty obvious, if we compare it to a section generated without a type plan, a lot of visual changes were made to the drawing. In essence, with type plans, we can customize all generated lines, and that per group of entities that were filtered out inside the type plan template. So for every step down a filter list, we have overwritten the properties of all lines that were generated for an entity falling under that filtering. As such, in this example, we gave all the structural entities a different color than all the other elements in our drawing. As such, with type plans and BricsCAD BIM, you can customize the entire look and feel of your 2D drawing. So all in all, if we compare it to the default documentation style of BricsCAD BIM, we have indeed been able to change the style significantly to correspond with the local government standards or to represent our own office style. Now that we have seen how to create a type plan from scratch, I'll end this session by showing you how you can import type plans from another BIM project into the current one. In V23, it's very easy to import type plans through the project browser. For that, we open one of the model or sheets DWGs of the project we want to use the type plan in. Next, in the project browser, hit the blue plus button in the Files tab. Then, Import Type Plans. And now simply navigate to an old project or wherever you save the type plan that was shared with you and click on a .tp folder. Once we imported the type plan, we see that this type plan is copied to our BIM project folder in the subfolder named Type Plans. In this case, I also import an area strategy plan, an installation strategy plan, a 1:200 concept plan, and a fire safety plan. When looking inside each of them, we see that the filter list changes, as well as the filter expressions and the styles that were used. In case of the area strategy, we will color the space hatch based on the spaces area. In case of the installation strategy, we highlight the installation ply only, and we make a color distinction between acoustic and thermal insulation. For the 1:200 concept plan, we just use a very simple window and door symbol, hide all the other symbols, and color the walls in a solid gray. Finally, for the fire safety plan, we customized the center line to encompass different colors depending on the different fire ratings. And that's it. As soon as we imported these type plans, we can use them in the Create Sheets dialog once again. Or find the imported type plans in the Type Plan drop-down property list of the viewport. Now, if you want to generate multiple times the same section entity, but with different type plans applied, that is no problem either. Just copy the viewport on the same sheet, apply another type plan, generate again, and ready. As such, we can see how different type plans give us very different visual representations, and how each representation can now tell its own story, such as the fire rating strategy here. Alternatively, copy your entire sheet altogether through the project browser, apply another type plan on your viewport of the second sheet, generate, and ready. This time you see the spaces colored in a different color depending on their areas. Finally, for our 1 to 200 concept plan, we again copy the viewport, we changed its scale, apply our concept type plan, generate, and ready. And if we zoom in, we see that we now have a simple line instead of an intricate symbol. Also remember that another way to make a new type plan is, of course, by duplicating, renaming, and editing one of the type plans from your project. To duplicate a type plan, simply right-click it in the Files tab of your project browser and hit Duplicate. Double-click to start editing, and off you go to make a slightly adapted type plan. Now that we have created all these different stylized plans, it's time to wrap up this session by giving you a small recap of everything we saw. First, we started the session by checking if our model contained all the needed data to be used in the type plan. Next, we saw how the default out-of-the-box BricsCAD documentation style looked. Then, we defined some symbols to be used in our type plans. We proceeded with defining a new type plan and using the symbol. To then compare the visual representation and the visual transformation of that type plan with the out-of-the-box documentation. We ended the session by importing some more ready-made type plans, and we saw a variety of possibilities, all enabled by type plans. So, are you convinced to try out type plans for yourself? Or maybe you just want to watch the other BIM sessions? In any case, thank you for your attention and see you in the next one.